Hello students and welcome to another video lecture on logic design. We have seen how Boolean expressions can be simplified using laws of Boolean algebra. In this video, I will introduce you to the concept of Karnaugh maps. Karnaugh maps are also called as KM or K-maps is a systematic method used for simplifying Boolean expressions. It is a chart or a graph which is made up of an arrangement of adjacent cells or squares. Notice the image to the right. Each square in this chart will represent some combination of variables in sum or product form. It is in fact very similar to that of a truth table because it shows the relationship between inputs and outputs. An important thing to know about K-maps is how many cells or squares does a K-map have? The answer is simple. A two-variable K-map will have 2 raised to 2 cells, that is 4. This is an example of a two-variable K-map. A three-variable K-map will have 2 raised to 3 cells, that is 8 cells. This is what a three-variable K-map will look like. On the other hand, a 4-variable K-map will have 2 raised to 4 cells, that is 16 cells. And this is what a 4-variable K-map looks like. From this, we can infer that if we want to draw an n-variable K-map, then we will have 2 raised to n cells. Any Boolean expression can be represented in two forms. The sum of products, also known as SOP, and the product of sum, also known as POS forms. Here are some examples of SOP expressions. Notice that the first equation is made up of two variables A and B in complemented and non-complemented forms. The second equation is made up of three variables A, B and C which are in complemented and non-complemented forms. Here are some examples of POS expressions. Notice that the first POS equation is made up of two variables A and B in complemented and non-complemented forms. The second has three variables A, B and C in complemented and non-complemented forms. The SOP expression is made up of a number of product terms which are added. That is why the term sum of products. If you consider the last equation, these are the product terms, and they are called as Minterms. On the other hand, the POS expression is made up of a number of sum terms which are multiplied. That is why they are given the term product of sums. If you consider the last equation, these are the sum terms, and they are called as Maxterms. Now for every minterm or maxterm in standard form, they should contain all the variables in the equation either in complemented or non-complemented forms. These are examples of standard SOP expressions. Notice that each product term is made up of all the variables in the equation either in complemented or non-complemented forms. These are examples of standard POS expressions. Notice that each sum term is made up of all the variables in the equation either in complemented or non-complemented form. Since these equations satisfy this clause, they are said to be standard forms of SOP and POS expressions respectively. Here are some examples of SOP expressions that are not in standard form. Notice that in some product terms there are some variables which are missing. That is the reason why these expressions are not in standard form. Here are some examples of POS expressions that are not in standard form. Notice that in some sum terms there are some variables which are missing. Here are a few differences between Minterms and Maxterms. Minterms are also called as product terms, whereas Maxterms are called as sum terms. A Minterm forms an SOP expression, whereas a Maxterm forms a POS expression. In a Minterm, a non-complemented variable is given the value of 1. In a Maxterm, a non-complemented variable is given the value of 0. In a Minterm, a complemented variable is given the value 0, and in a Maxterm, a complemented variable is given the value of 1. So if this is an example of a standard SOP expression, the value of each Minterm would be, the first Minterm is A B bar, which is basically 1 0, where A is represented as 1 and B dash is represented as 0. The second Minterm has a value 0 1, where A dash is 0 and B is 1. If this is an example of a standard POS expression, the value of each Maxterm would be, the first term A plus B is 0 0. Since A and B are both non-complemented and they are represented as 0. The second Maxterm is A bar plus B bar and is represented as 1 1, since A bar and B bar are both complemented and are hence represented as 1. Going back to the differences, Minterms are represented with lowercase m and Maxterms are represented with uppercase M. You can see the examples as the last points in the table. Just a quick recap to help you recollect what is SOP. SOP stands for sum of products. This is an example of an SOP expression which is in standard form. It is made up of product terms which are added. Hence we say sum of products. The product terms are A, B, C bar, A, B bar C, A bar B, C and A bar B bar C bar. These product terms are also called as Minterms. Minterms are represented using lowercase m. A complemented variable in a Minterm is 0 and a non-complemented variable is represented as 1. Therefore, the Minterm A, B, C bar is 1 1 0. The Minterm A, B bar C is 1 0 1. Minterm A bar B, C is 0 1 1 and Minterm A bar B bar C bar is 0 0 0. In terms of lowercase m, it can be represented using decimal numbers for the equivalent binary Minterms as M0, M3, M5 and M6. This is also an SOP expression, but note that it is not in standard form. This is because in each product term there are some variables that are missing. Just a quick recap to help you recollect what is POS. POS stands for product of sum. This is an example of a POS expression which is represented in standard form. It is made up of sum terms that are multiplied. Hence we say product of sum. The product terms are A plus B plus C bar, A plus B bar plus C, A bar plus B plus C, and A bar plus B bar plus C bar. These sum terms are called as max terms. Max terms can be represented using uppercase M. A complemented variable in a max term is 1 and a non-complemented variable is represented as 0. Therefore, the max term A plus B plus C bar is 0, 0, 1. The max term A plus B bar plus C is 0, 1, 0. The max term A bar plus B plus C is equal to 1, 0, 0. And the max term A bar plus B bar plus C bar is 1, 1, 1. In terms of uppercase M, it can be represented using decimal numbers for the equivalent binary max terms as M1, M2, M4 and M7. This is also a POS expression, but note that it is not in standard form. This is because in each sum term there are some variables that are missing. That's all for now. Stay tuned to the classroom for another video.